Hello, so this is a revision video for IB Chemistry S2.2.5, Electronegativity and Bond Polarity. Electronegativity is the power of an atom to attract electrons to itself. It's a relative value and doesn't have any units. The most commonly used scale to compare relative values is the Pauling scale, and values are found in the IB Chemistry data booklet. Electronegativity is really useful and can help predict whether a bond is likely to be ionic, polar covalent, or nonpolar covalent. The electronegativity of an atom depends on three main factors: the nuclear charge of the atom, the atomic radius, and shielding. The nuclear charge is really important because the greater the number of protons in the nucleus, the greater the attraction it can have to bonding electrons. The atomic radius is important because the smaller the atom, the closer the bonding electron pairs are to the nucleus of the atom, given a stronger force of attraction. A greater level of shielding means more inner shells and subshells, reducing the attraction between the nucleus and bonding electrons. Electronegativity increases across a period from left to right. This is because atomic radius decreases and nuclear charge increases, but the level of shielding stays roughly the same. This means a greater attraction between a shared pair of electrons and the nucleus of the atom. Electronegativity decreases down a group from top to bottom. This is because atomic radius and shielding increases. The outer electrons get further from the nucleus and are less strongly attracted to it. We can predict a bond type by comparing the Pauling electronegativity values of two bonded atoms. If the difference is very large, typically greater than 1.7, the bond is effectively ionic. Because the electronegativity of one atom is so much greater than the other, it essentially attracts the bonding electrons towards itself and ends up taking them and becoming a negatively charged ion. The atom with the lower electronegativity will therefore lose the electron density and become a positively charged ion. If the difference, however, is only moderate, so somewhere between 0.5 and 1.7, the bond becomes polar covalent. This is when the electrons in the bond are shared unequally. The electrons will be more attracted towards the atom with the higher electronegativity, and this atom will end up with a partial negative charge. And the atom with a lower electronegativity will end up with a partial positive charge. This is why the bond is described as polar, because it has two opposite poles to it, a negative end and a positive end. The greater the difference in electronegativity, the greater the polarity of the bond. We can show the polarity of a bond, or bond dipole, in two ways. We can use partial charges of delta positive and delta negative, or we can use vector arrows, with the arrowhead pointing towards the more electronegative atom. If the difference in electronegativity between the two bonded atoms is very small or zero, the bond is nonpolar covalent. The bonding electrons are shared equally between the two atoms, and no atom has a greater share of the electrons than the other. Exam tip here: always remember it is the difference in electronegativity between two bonding atoms that matters. It is never the individual electronegativities themselves. You can have two atoms of very high electronegativities bonded together, but the bond is still nonpolar because the difference in electronegativity between them is very small.